Combustion. Burning of a substance in the presence of air is known as combustion. When a substance is burnt, it produces carbon dioxide and energy in the form of heat. Some materials are combustible, while some are non-combustible. The materials which burn readily are known as combustible materials. For example, paper, wood, kerosene, diesel, petrol, straw, etc. The materials which do not burn readily are known as non-combustible materials. For example, glass, metals, ceramics, etc. Combustion. Let us do an activity to demonstrate the process of combustion. Take a magnesium ribbon and light it. After some time, you will observe that magnesium burns with a bright white light to form magnesium oxide, emitting heat and light. Now hold a piece of charcoal using a pair of tongs and bring it near the burner. You will observe that the coal burns in air to produce carbon dioxide, heat and light. Thus, in combustion, combustible materials burn to produce heat and light.
Characteristics of a good fuel. A good fuel is one that has low ignition temperature and easily available, has a high calorific value, and is cheap and easy to transport. It does not cause pollution or leaves no unwanted residue upon burning.
Combustion. Let us do an activity to demonstrate combustibility and non-combustibility of materials. Take some materials such as straw, matchsticks, kerosene oil, paper, iron nails, stone pieces, and glass. Try to burn each of these materials one by one and observe. You will observe that straw, matchstick, kerosene oil, and paper catch fire easily, while iron nails, stone pieces, and glass do not catch fire. By this activity, we can conclude that straw, matchsticks, kerosene oil, and paper are combustible materials, while iron nails, stone pieces, and glass are non-combustible materials. Conditions required for combustion. Presence of a combustible substance. The attainment of the correct temperature for ignition or ignition temperature. Presence of a supporter of combustion such as oxygen. Combustion. Let us do an activity to demonstrate the conditions required for combustion to take place. Take a lighted candle and fix it on a table. Put a glass chimney over the candle and rest it on a few wooden blocks in such a way that air can enter the chimney. Observe the flame. You will observe that the candle burns freely. Now, remove the wooden blocks and let the chimney rest on the table and observe. You will notice that when air does not enter the chimney from below, the flame flickers and produces smoke. Finally, put a glass plate over the chimney and watch the flame again. You will observe that the flame finally gets extinguished because air is not available. By this activity, we can conclude that oxygen present in the air is necessary for the process of combustion. Combustion. Let us do an activity to demonstrate that oxygen is necessary for combustion. Take a piece of burning wood and place it on an iron plate. Now cover it with a glass jar and observe. You will observe that the piece of burning wood gets extinguished after some time because the supply of oxygen has been stopped. By this activity, we can conclude that oxygen is necessary to support the process of combustion. Ignition temperature. Take a piece of paper and a piece of wood and try to burn each of them with the help of a matchstick. You will observe that the piece of paper catches fire easily, while wood does not catch fire easily. Now pour some kerosene oil on the wood and burn it. You will observe that this time the wood catches fire easily. By this activity, we can conclude that different materials catch fire at different temperatures. Thus, the minimum temperature at which a combustible substance catches fire is called its ignition temperature. Ignition temperature. Let us do an activity to demonstrate ignition temperature of materials. Make 2 paper cups by folding a sheet of paper. Fill 50 milliliter of water in one of the cups. Now heat both the cups separately with a candle. After some time, you will observe that the empty paper cup burns quickly while the paper cup containing water does not burn, but it becomes hot because the water in the cup absorbs the heat and distributes it to all the parts that holds water. So, in the presence of water, the paper does not attain its ignition temperature. Hence, it does not burn. By this activity, we can conclude that substances having very low ignition temperature can catch fire easily and are therefore called inflammable substances. How do we control fire? You might have seen or heard of fires breaking out in homes, shops, and factories. You might have seen a fire brigade also. Fire brigade pours water on the fire. Water cools the combustible material so that its temperature is brought below its ignition temperature. This prevents the fire from spreading. Water vapors also surround the combustible material, helping in cutting off the supply of air. So, the fire is extinguished. As we know, there are 3 essential requirements for igniting fire: fuel, air, and heat. Fire can be controlled by removing one or more of these requirements. Fire extinguishers. The most common fire extinguisher is water, but water works only when things like wood and paper are on fire. If an electrical equipment is on fire, water may conduct electricity and harm those who are trying to put off the fire. Water is also not suitable for fires involving oil and petrol. For fires involving electrical equipments and inflammable materials like petrol, carbon dioxide, CO2, is the best extinguisher. CO2, being heavier than oxygen, covers the fire like a blanket. Since the contact between the fuel and oxygen is cut off, the fire is controlled. The added advantage of CO2 is that in most cases it does not harm the electrical equipment. It can be stored at high pressure as a liquid in cylinders. When released from the cylinder, CO2 expands enormously in volume and cools down. So, it not only forms a blanket around the fire but also brings down the temperature of the fuel. That is why it is an excellent fire extinguisher. Types of combustion. Slow combustion. In certain cases, we find that natural process of oxidation is quite slow. For example, when iron is exposed to air, it gets corroded and forms rust, which is iron oxide. Spontaneous combustion. There are some combustible substances that catch fire on their own when they are exposed to air. This phenomena is known as spontaneous combustion. For example, sodium catches fire spontaneously in air. Rapid combustion. When a combustible material burns quickly, the process is called rapid combustion. Burning of wax candle and domestic fuel (LPG) is the example of rapid combustion. Explosion. When a combustible substance burns very rapidly with the evolution of tremendous heat, light and sound energy, it is called an explosion. For example, explosion of bomb. When you light a candle, you may observe zones in the flame. These are zone of complete combustion or non-luminous zone, zone of incomplete combustion or luminous zone, zone of no combustion. Structure of a flame. Let us do an activity to demonstrate the structure of a flame. Take a candle and light it. Hold a glass tube open at both the ends with a pair of tongs and introduce its one end in the dark zone of a non-flickering candle flame. Bring a lighted matchstick near the other end of the glass tube. A small flame is produced. The vapors of wax coming out of this glass tube cause this flame. When the candle flame is steady, hold a clean glass slide with a pair of tongs and introduce it into the luminous zone of the flame for about 10 seconds. Now remove it. You will observe a circular blackish ring on the glass slide. It indicates the deposition of unburned carbon particles present in the luminous zone of the flame. Now hold a thin long copper wire just inside the flame for about 30 seconds. You will observe that the portion of the copper wire just outside the flame gets red hot. It indicates that the non-luminous zone of the flame has a high temperature.
Zones of a flame. There are 3 zones in a flame. Bring a candle and light it with a matchstick. On observing carefully, we find that there are 3 zones in a flame, namely outer zone, zone of complete combustion, blue color, middle zone of partial combustion, yellow color, and innermost zone of unburnt wax vapors, black color.
Beautiful cup. When you burn a candle, you can see the formation of a beautiful cup. This cup is formed as the air near the candle moves upwards due to heat of the candle. Michael Faraday explained that this happens because of the capillary action of the wick that draws the liquid wax up to the flame, where it vaporizes. Train of fire. Let us do an activity to demonstrate what a train of fire is. Take a candle and light it. After some time, snuff the candle out. You will observe a smelly stream of gas and some minute smoky particles rising up from the wick for just a few seconds after the flame is blown out. This is known as the train of fire. Rising up of a candle flame. The flame we see is drawn out by the rising column of hot air and rises to a good height for such a small flame. The surrounding, denser air pushes the flame up because hot burning gases comprising the flame expand and become less dense than the surrounding cooler air. In other words, flame consists of gases so hot that they glow. Since hot gases expand and become less dense than the surrounding air, the flame is lighter than an equal volume of air. Fuels. The combustible substance burnt for releasing and using its heat energy is known as fuel. They may exist in solid, liquid, and gaseous states. Solid fuels. On burning, they deposit a lot of smoke and residue. They need more space for storage. For example, coal and wood. Liquid fuels. They are mostly obtained from petroleum as byproducts and formed as a result of fractional distillation of petroleum. Commonly used liquid fuels are kerosene, petrol, diesel, etc. Gaseous fuels. They neither leave any residue on burning nor do they emit any smoke on combustion. They are used at domestic as well as industrial level. For example, LPG and CNG. Calorific value. The amount of heat produced by 1 gram of fuel when it is completely burnt is known as its calorific value. All fuels do not produce the same amount of heat on burning. The efficiency of a fuel is determined by its calorific value. Burning of fuels produces harmful byproducts. Carbon dioxide is released when fuels are burnt, which leads to global warming. Burning of fuels containing carbon causes serious health problems. When the fuel is burnt, the unburnt particles of carbon remain suspended in the atmosphere and cause respiratory problems such as asthma. Burning fuels such as diesel and coal release sulfur dioxide. It has corrosive effects and is also suffocative in nature. Acid rain is another serious problem which is damaging old monuments such as the Taj Mahal. Managing energy resources. As we know, coal and petroleum are obtained by the fossilization of dead plants and animals. The Earth's natural resources are shrinking day by day due to several reasons. When a country develops, its energy demand increases and that leads to increased use of fossil fuels. most of the energy demand is met by the fossil fuels. As far as alternative methods are concerned, we should gradually switch over to a method of cooking that involves solar heating. Use of solar cookers for cooking and heating purpose is quite common in many places today. In villages, biogas is widely used as domestic fuel, since plenty of material is available for decomposition to produce biogas.